Okay, so there was a goof in today's lesson, i.e. Friday's lesson, and it's not a bad thing because it actually brings up an important point that needs to be taught anyway, and it's about commutativity and matrix multiplication. Commutativity, as you know, is something with real numbers where you can swap the order and basically get the same result. So with just regular real numbers, you've got a plus b equals b plus a, or a times b equals b times a. We know that's true for reals. But matrices are not real numbers. We've got the goof made was when I quickly hastily put the answers up. I haven't looked at the quiz for 12 months and I didn't read something very important, and the order of the product y times x and not x times y, and I quickly put up all the answers for x times y, and a whole lot of people got their answers wrong, and it wasn't necessarily their fault. It was the fact that I had put the answers up for x, y and not as y, x as it should have been. So please note, this is important to note, in general matrix multiplication is not commutative. There are a small number of exceptions, but generally speaking matrix multiplication is not commutative. So x times y does not equal y times x, where x and y are matrices. So something important to note. And if you want to have a look at the difference it makes, I've just quickly, for one of the quizzes, depending on which quiz sheet you basically were given, one of them looks like that. X and y are those. Even if you had one of the others, the same thing goes. If you go x times y, you get that, which might have been the solution I put up on the board, but the true answer is y times x is that, and as you can see the answers are completely different. If you think about why that happens, it's all about the combinations. If you go x times y, you're going 1 times 1 plus 6 times 5 plus 4 times 3, which is 1 plus 30 is 31, 31 plus 12 is 43, and so on. If you've got y times x the other way around, you have different combinations happening. For example, if we look at what goes in position 1, 3 here, 56, that's because we're going 1 times 1 plus 6 going across the first matrix. Okay, across the order is important because we always go across the row of the first matrix and down the first column in the first instance, don't we, of the second matrix, and y is first and x is second in that order. So 1 by 1 plus 6 by 4.5 plus 4 times 7, and you get 56. And if you extended that idea, you'd see the combinations of products and sums are all different, and therefore you get different elements in the whole. Results are not the same. So matrix multiplication in general is not commutative. X times y does not equal y times x.